Hello world, it's me, Miss Lloyd. Welcome to another episode of Math with Miss Lloyd. I am Miss Lloyd. Yeah, that was probably a little bit too much, but I've had coffee, and so you're just gonna have to deal with it. All right, so today we are solving non-quadratic polynomial equations. The first thing we're going to look at is factoring. And so, yes, this isn't a quadratic, but I do notice that I can do something that I could normally do with quadratics. I see that they have something in common, a GCF that I can take out. We got a 3 and an x squared. When I am taking out a GCF, I put it out into the front. It's like that gift your grandma gave you. You don't want to throw it away. You love Granny. And then we'd be left with a 3x squared minus a 4. Because of the multiplicative property of 0, I can set each of these equal to 0. I'm going to start with a 3x squared. I would divide my 3 over to get the x by itself, and then take the square root, and I end up with x equal to 0. This is technically a double root. Whenever we take the square root of 0, it would be 0 times another 0, 0 times itself. You could have a plus minus, but positive 0 and negative 0. 0 is not positive nor negative. I'm going to put a little dr to remind myself that this is a double root. And then I'm going to do the same thing for my 3x squared minus 4. Adding my 4 to both sides, dividing that 3 over, taking the square root. I have a plus minus. Square root of 4 is going to give me 2 on top. And I don't know the square root of 3. I also don't like that we have the square root in the bottom, so I'm going to rationalize this real quick. And I do have 2 solutions here as well. A trick to make sure that you found everything is to look at the highest exponent. So here we have a 4 as our highest exponent. I have 2 solutions with my double 0, and I have 2 solutions with a positive 2 square root 3 over 3 and a negative 2 square root 3 over 3. I've got all 4 of my solutions, and I'm ready to move on. We're going to go in this direction. Next, this is set up as a trinomial, and if I didn't have the x to the fourth and the x squared, it is something that I could be able to factor using my little M&A method. So whenever I have something like that where I could possibly see it working out if this was an x squared and this was an x, I use what I call U substitution. It's also something that you would use in calculus quite a bit. So preview. So in this case, I would want just a solitary x, or we could say a u, where the x squared is. So instead of x squared, I'm going to be putting a u, which means that instead of the x to the fourth, that's the same as u squared. X squared times x squared gives us x to the fourth power. So now that I just have the squared and the u, I can look at my M&A. So I'm multiplying to get 36. And adding to get negative 37. I kind of already can see what numbers I would use. 36 and 1 would give me, multiply to give me 36. If they're both negative, 36 minus 1, negative 36 minus 1 would give me negative 37. So I'm going to split my middle. I can take a 9u out of the first group, a negative 1 out of the second. I always want that first term to be positive. And so now my factors are that u minus 4 that they had in common, and then 9u minus 1. Now I can use a multiplicative inverse property, or multiplicative property of 0, When I set u minus 4 equal to 0, u would be equal to 4. I can do the same thing to that 9u minus 1. And I would end up with u equal to 1 over 9. So then from here, remember this is u, and I want to figure out what x is. So this is when that substitution comes back. So I know that u is equal to x squared, and you can plug it into either of those u substitutions. It doesn't matter, you're going to get the same thing. I like to work with smaller exponents, so I'm going to use the u, and I'm going to plug each of these u's that I found in. So I'm going to start with my 4. So instead of u, 4, we said u is equal to 4, so we can exchange that. So 4 is equal to x squared. I'm going to take the square root to get just my x. And I would end up with plus minus 2 is equal to x. So I've got two solutions there. I'm now going to replace with the 1/9. When I take this square root, the square root of 1 is 1, the square root of 9 is 3. Again, plus minus, and that is equal to x. So now I have two solutions. I have 4 total solutions when we started off with an x to the 4th. And we're done. Next, we are looking at radicals. One of my first steps when I'm solving with a radical like this is to isolate the radical. I want to get that radical by itself. So I'm going to start by subtracting that 2 over. I don't like the negative in front, so we're going to divide that. Now that I've gotten that alone, I'm going to square both sides in order to eliminate that square root. Squaring and square roots are inverses of each other. And when I'm squaring both sides. So I'm putting that in parentheses, and we're going to have to do some major distribution here. So doing that distribution, now I can see that I'm likely going to be able to try out m and a, but in order to do that, I have to have one side equal to 0. So I'm going to move everything over to where the positive x squared is. Now that I've got that, I can try out m and a. So I'd be multiplying to get negative 36 and adding to get 5. So numbers that could do that, 9 and 4. I would have to have a positive 9 and a negative 4 in order for them to add to get positive 5. So my factors will be x plus 9 and x minus 4. So remember, because I have a 1 in the front of my x squared, I don't have to split the middle. I would set each one of these equal to 0, and I would end up with an x equal to negative 9 and an x equal to positive 4. And we started, although when it comes to square roots, we do have to remember to check for extraneous solutions. So underneath the square root, we don't like taking square roots of negatives because it would end up being imaginary, and we don't want to have to worry about imaginaries right now. So in my mind, I am plugging in a negative 9 for my x. And so 40, and then the 9 and the 9 would give me 81. So 40 plus my 81 would give me 121. The square root of 121 is 11. We have that negative on the outside, which would make it negative 11 plus 2, which would give me negative 9. So that works out. And if I try to plug in 4 into that x, 9 times the 4 would give me 36. 40 minus 36 would give me 4. Square root of 4 would give me 2. Negative 2 plus 2 would give me 0 and not 4, so that one does not work out. So we've got an extraneous solution here, and negative 9 is the only one that actually works out. Next, when we're looking at exponents. We're wanting to get rid of them. I like to take both sides once everything's been isolated. So the only thing on this side is whatever has the exponent. It's already isolated. When things are already isolated, I like to take both sides to the reciprocal of the exponent. So I do this because whenever we have an exponent to an exponent, we have to multiply. And so if I multiply a fraction by its reciprocal, so the flipped version, it's going to end up giving me 1. And we don't have to have that exponent of 1 there. And of course, what I do to one side, I have to do to the other. So I'm going to do this to the 3/2. So my exponents here will cancel out on the left side. And when I'm doing to the 3/2, I'm going to write this as a radical form. So I have 2 on the bottom, which means I'm taking a square root. Remember, it's exponent over index. So the index is the type of root I have. And then I would have this to an exponent of 3. And I know the square root of 16. So the square root of 16 is going to give us 4. So we did take a square root here, so we're going to have plus minus. And this is going to be to the third power. And so 4 to the third power will give us 64. And I'm going to move my 5. And when it comes to 5 and 64, I can combine those. So I'm going to start with 5 plus the 64. 5 plus 64 will give me 69. And then 5 minus 64 will give me negative 59. And again, we want to check our solutions because this is technically a cubed root. These I like to just plug into the calculator. If it gives you an error, then it's not okay. If it gives you 16, then you're all good. And checking both of these, they do end up working out. And these are the last two that I'm going to go over, and then I have another group of equations that I'm going to work out with my kiddos, my babies. So this first one, we have a bunch of fractions. I hate multiplying fractions. I hate working with fractions, solving with fractions. So my idea is to get rid of them. And in order to do that, we're going to use the LCD, the least common denominator. So when it comes to the LCD, so in my mind, I know that I want to cancel out an x. So in order to cancel out this x on the bottom, I would have to multiply it by an x on top. What I do to one term, I have to do to all the others. So they all get an x. The x is not going to cancel out this x plus 3, though. In order to cancel out an x plus 3, I have to multiply by an x plus 3. So I'm going to give everything an x plus 3 so that that cancels. So that would be my LCD, the x and the x plus 3. It's going to cancel everything out. So for my first fraction, I would just be left with the 4 and the x plus 3. In the middle, the x plus 3's cancel out, so I'm just left with the 2x. And then there's nothing to cancel out at the end. So this negative 3x times the x plus 3 is all going to remain. So now I'm going to do some distribution. It looks like I'm going to have to do some M&A. I'm going to end up with an x squared somewhere. So I'm going to set one side equal to 0. I personally don't like my variable squareds to be negative. So I'm going to move my negative 3x squared so that it's now positive. Now that I've got this set equal to 0, I could do the M&A, but I notice that everything is divisible by 3, so I'm going to take a 3 out of everything and divide it to the other side so that it just cancels. And now I'm looking at things that multiply to give me 4 and add to give me 5. So that would be 4 and 1, and everything's positive, so we're going to have positive factors. Setting each equal to 0, I would end up with an x equal to negative 4 and an x equal to negative 1. And again, we want to check our solutions. Because we have our x in the denominator, we want to make sure that if we were to plug something in, it wouldn't give us 0 in the denominator. We're not allowed to divide by 0, and that's how the world explodes. And then there's no more tacos because we're the only planet with tacos, so we have to save it. One, by recycling, and also by not dividing by 0, let's be honest. So plugging in a negative 4, it would be okay. Negative 4 plus 3 would give me negative 1. That's totally cool to have in the denominator. And then plugging in a negative 1, I would have a negative 1, and negative 1 plus 3 gives me a positive 2. So these are both pretty awesome solutions. My last one I'm going to talk about is my absolute value. So when we're solving absolute value, we want to make two equations out of this. We want to make a positive one and a negative. And when I talk about positive and negative, I'm talking about the stuff inside the absolute value. So we know absolute value makes things positive. It's talking about distance, and we always have a positive distance. So the stuff inside could be a positive value, or it could be negative. And so we're going to make one of each of those equations in order to satisfy those possibilities. And so from here, I'm going to solve each one individually. So I'm going to first focus on the positive one. So I'd have x being equal to 6 and x being equal to negative 3. We do want to check our solutions. So in here, because of those absolute values, it could change what we see on the other side. So if I were to plug in my 6, the 6 squared would give me 36, plus the 4 times the 6 would give me 24. And 7 times the 6 would give me 42, plus my 18. 36 plus my 24 would give me 60. Absolute value of 60 is still 60. And then 42 plus the 18 also gives me 60, so that works out. And I want to do the same thing with my negative 3. So negative 3 squared would give me 9. 4 times the negative 3 would give me negative 12. And then I would have negative 21 with the 7 times the 3, negative 3. 9 minus the 12 would give me negative 3. Absolute value of negative 3 is just positive 3. And negative 21 plus 18 would give me negative 3, but negative 3 and positive 3 aren't the same thing, so that one doesn't actually work out. Now we solve the negative side. So I've got x equal to negative 9 and x equal to negative 2. I would end up doing the same plugging in, and when I do that plugging in, negative 9 ends up not working, but negative 2 totally does. So then my solutions here are going to be positive 6 and negative 2. I'm going to make sure you check yourself before you wreck yourself. And that's the last one that I'm going over with you guys. If you found this helpful, please like and subscribe. If you think someone else could find this helpful, please feel free to share it. Spread the love.